Hey guys, Mr. McKinney here, just going through the pyramid problem in case you missed it in class today for some reason or needed to see it again. So we've got a square pyramid, square meaning that the base is a square, where sand is coming in to this pyramid and it's dropping down and it's filling this pyramid up. The height is 8 meters. The side length of the base is also 8 meters. Find the rate at which the height of the sand is changing when the height is 3 meters. And the hint is to be thinking about the air. Because as the sand is filling up, let's say that it's filled up to 3 meters, we don't have a shape that we can easily take the volume of. We don't have a formula for a truncated pyramid or a pyramid with the top chopped off. There's not an easy formula for that. So what we want to do is we want to think about the air, because the air still has the shape of a pyramid. And whatever rate the sand is rising is the same rate that the air is shrinking, or the height of the air is shrinking. So as the sand level rises, the air level is going to, or like the amount of air is shrinking, and those have to be at the same rate, like the rate at which the height of the sand is increasing and the rate at which the height of the air pyramid is decreasing. Those are going to be the same thing. So I'm going to be thinking about the air, not about the actual sand. And then we can answer the question about the sand by thinking about the air. So the air is still a pyramid. The formula for a pyramid is 1/3 capital B times H, where B is the area of the base. Since the base is a square on this one, we're going to say that B is equal to S squared, where S is the side length. All right, so I can rewrite this as 1/3 S squared H. Now, the key to this problem is that the height and the side length are the same. They're both 8 meters. That's not particularly important right now. What's important is that they are the same. And as we fill it with sand, whatever the length of the side is always going to be the same as the height when we're thinking about the pyramid of air. So we know that S is equal to H at all times. It starts with both of them being equal to 8, but then as we fill it up, that's going to change, but they're always equal to each other. So instead of writing the volume as 1/3 S squared times H, I can write the volume as 1/3 H squared times H, or just H cubed. Just replace S with H, and now we can take the derivative. So they've given us a rate that has a volume per time, which means that this is dV dt. So I'm taking the derivative of volume with respect to time. So derivative over here, I'm going to multiply the 3 in front, 1/3 times 3 times H squared, and then the derivative of H with respect to t. So dH dt. These are going to cancel. So dV dt equals H squared times dH dt. So I want to know what H is. And some of you guys are going to be tempted to plug in 3, but that's the height of the sand. So if the sand is 3, that means at that instant the air would be 5, because together they need to make the total height, which was 8. So at this instant, we're going to be looking at H as 5. So dV dt equals H squared dH dt. I want to know the rate at which the height is changing. So this is what I want to find. So I'm going to divide both sides by H squared. So dH dt is going to be dV dt divided by H squared. dV dt was given to us in the problem. Now, if we're talking about the air, it would have a negative volume, or a negative volume rate, because it's leaving, the amount of air is leaving. So we'd have negative 0.25. H, we said was 5, because the height of the pyramid of air is 5. So divided by 5 squared. Technically, you can just leave it like this. Let's go ahead and simplify it. So negative 0.01. Now we're talking about height with respect to time. So this would be meters per second. Now again, this was for the air. So the sand is rising. the rate of the height of the air is shrinking, which is why it was negative. But for the sand, dH dt would be the same value, just positive. So the rate of change of the sand would be 0.1 meters per second when the height of the sand is 3 meters. Hope this was helpful. Email me if you have questions.